To perform COT analysis, you need to initialize the COT initializations. And to do COT initializations, you need to first perform the Layup builder. Layup builder is actually assembly of the kinematic file that you created via the kinematic CAD file. So we go through this step quickly and we check how to quickly make a layup and then initialize the COT initializations. So first we go to the to generate the path quickly like that, and we create the path. It's like that. We set the laser directions. And we redo this again. So we set the laser direction here. We leave it adjusted. And when you are done, you can save and set the initial position and end positions. But before that, you need to save the mesh. Mesh is actually these nodes that are created here. So when you do that, you save the mesh, you set the name. For example, example 1, and save it. And you now set the start point and set the finish point and save it. So you see the name of the amended tape mesh file here. That this is the address that was created. Click on OK, and the data will be saved. Now we generate the second path. We remove this one. We move it a little bit. We generated a little bit different orientations. And we click on the creating the path. Again, we save the mesh. We set a name for that. We check the positions and the kinematic, set the start point, and then click on here to set the endpoint, like that. And then we click on Save Path Info. And this is the amended mesh. Now we created two kinematic on the flat panel, and we associated the mesh corresponding to each one. Now this next step would go to the Layup builder and create the layup. So we go to the Layup builder from the UOT COT setup. This is the Layup builder, and we need to load the kinematics that we just created. So the kinematic that we just created was this one, which was created just now. And the second one was test example 2. So we loaded these two kinematics here. We now double click it or push this add button. So we bring it on the left side. And we add also the second one. So both were added. now we need to also load the STL file of the base flat panel, and also the mesh file. That I have it here. So when you load it, these tick boxes will show up. And you could also, if you have the save it before this layup, you could also click on this one, the load layup, setting would be saved. The setting the mesh is about if you have a caret surface, you could assign the higher number, but which is basically a 0 and 1 to those values. And you could check the help of the software for more information. We don't change it now. And when you're done, you could click on Build Layup 3D to see that if the layout was built. Now you will see the 2 layers build up like that. And if I zoom in, you will see that they are on top of each other. Like this one, and the boundary conditions are made automatically. So at this moment, you are ready to save the layup and go to the COT initializations. So you need to go to Save Layup and name it Layup save it as for this shape. So then you go to the UOT-COT setup and go to the initialization of the COT. You give a random number here because we need to load the layup. We need to load the layup and then select the layup that we just built. So as you see, it's basically on a default, it assumes that we have one tooling, which is a default tooling here. And the steel file is already loaded here. We have 2 paths as a tape 1 and tape 2. And now we could assign the material for each of them. I set the currently material for the peak with a CP of 1500. And I do assign the tooling for as a steel. We could either also increase the extra tooling if you like, for example, changing from 1 to 4. For example, if you have a 1 layer of the Kapton layer or 1 layer of the any glass fiber, carbon fiber, you could add this. Just click on it, and now we have tooling 2 and tooling 3. You could set the mesh according to the tooling 2 or tooling 3, and add extra layer on top of the tooling, and then the tapes would be placed on them. But now we go back to the previous condition with the 1 tooling. So it was discussed before that you could change the solver from explicit to implicit by clicking on them. You could change the centering method from planar to axial, and you could assign the material, and this is the heat convection coefficients at the irradiation zone and the rest of the location, and the second value is the consolidations coefficient. And if we have more than 1 material on a part, you could click on the +1 material and assign the second or third material for part of the body if the elements are assigned with a set. And here you could assign initial value. And if initial value are set as a fixed value, you could tick this box. So now you will see that we load the layup. We could also now save the initializations file that we now have. Please note that here we have a layer kinematic repeat, which is not useful for the COT analysis, because the COT only works based on the number of tips that we defined here on this window. And this layer repeat is only for the UOT mode. Well, the rest would be the same, except this delay layers, which here is also for the UOT only. For delay layers, we have here in the layout builder that if you would like to have a delay between the layers, you could add them. And the layers, for example, from one layer to another would be a specific delay. Or if you have a specific power, laser power, for example, per layer, then you could assign it here and then save the layup. Then when you go to the COT or UOT initialization here, you could also set like a read power from the layup. So this is just a tick box that it reads the value from here, from the layout builder. Now, when you are done, the same case, you could click on OK, or before that, click on Save Initialization Method, that you could save it as a COT initialization for simple plate. Then this file would be useful later for the COT analysis. Then click on OK, set the name, and you're done. So that was how the layout builder works, basically to create the layup for the COT analysis and the COT initializations for the later the COT thermal analysis, which is a continuous optical thermal models.